We can also subtract. So if you want to do 50 minus 50, you could do that. And I'll give you some time to catch up here in just a second. I'm just going to do a few print statements, and we'll take a look at them, and then we'll move on to some more math as well. We can also do 50 times 50, and we'll just use the little star or the asterisk. We'll just say multiply. And we'll also...
I think what I will do is actually change it to Linux. Guys are able to see Linux, right? I think you guys can see Linux here. Where else? Wait. Where else can you stream? Wait, just wait. Where else can you stream apart from Kick and Twitch and have more viewers faster? YouTube is doing. I can't do TikTok now. Trovo. All right. Okay. Twitch. I'm not able to. Okay, so how do I actually wait? How do I stream on Twitch now? How do I get the stream key and URL from Twitch? Profile, create a dashboard, settings, stream. There's only primary key. Yeah, but when I modify, this is what they're asking. Look. So for Twitch, these are what they need. I'm just going to do that. And I'm just going to do this, OBS, paste, OK, start. Oh, we are recording on YouTube, Twitch, and Kick.
So kind of moving.
Holy shit, we're actually
So kind of moving.
nice. Thick, right?
do 50 divided.
So let's just do some math. I'm just going to write hashtag maths print 50 plus 50. Then you can do 50 minus 50. You can do 50 plus 50, 50 minus 50, 50 times 50, 50 divide 50, 50 square 50. You can do minus, multiply, divide. Yeah. Simple operations. I mean, you can do square root. You can do 50 square. And then we're going to save it. Oh, shit. We are inside the directory. So Python 3 first.py. Okay. I'm not able to run the maths program.
By 50. We'll just say divide. So if we save that, you can take a second to catch up. You can see we are just doing simple math here. We should expect 100. We should expect 0. We should expect 1 here and 2500 if my mental math is correct. So I'm going to go ahead and print this out. Okay, we've got 100, 0, 2500, and...
But then I'm not able to run that. Why? So I'm not able to run this code. Why is that? Control S, S, okay. Wait, stop. And let's close this. So I'm not able to, so I did 50 square. Did I miss anything? Actually, what was the difference between his code and mine?
Mental math is correct. So I'm gonna go ahead and print this out. Okay, we've got
But then why doesn't mine work then? So let's say Python 3 first.py. Okay, now it's working. All right, cool. Now we're working. Fun.
got 100, 0, 2500, and 1.0. So this 1.0 is a little bit different. This is what's known as a float.
Yeah, I know. There's a reason why. So when you go here, when you go here, so what I'm going to do is write print 50 divide 50, save that, Python 3 first.py, that's going to be 1. Cool. With this one here.
Everything else that has come out so far is just an integer. And we'll talk a little bit about that here in just a few minutes, but know that integers are on the left-hand side. And if we don't have a decimal point here, we're looking at integers. And on the right-hand side, when we see anything on the right-hand side of the decimal, we're looking at what is called a float. And that becomes very important depending on when we need it. For now, we're going to keep worrying about math. We'll get into integers and floats in just a little bit. So another thing that math built into Python can do is it can do PEMDAS. If you've never heard of PEMDAS, please excuse my dear Aunt Sally. So parentheses, exponents, multiply, divide, add, subtract. You may have had something different within your educational experience, but it will do that for you. So if you do 50 plus 50 minus 50 times 50 divided by 50, it will give you the answer. I don't know that mental math offhand. Another thing that we can do are exponents. So we can print, say, 50 to the second power, which is the same thing as 50 times 50, which would be 2500 as well. And we can get exponents out of this. And we'll actually go ahead and save this and run this here because the next stuff I want to be able to lay out clearly. So you can see that we have successfully done the math here, did it for us, awesome. And it also did the exponent for us as well. So now, a couple of weird things with division. So you saw the 1.0.
I want to know why. And youtube.com. And twitch.tv/Sakarsad. Sakarsad Ahmed.
thing that we can do in here.
Just wait.
Zero before. Well, we have a few things that we can do. For example, the 50 divided by 6, but using a
That's a modulus of 6, meaning reminder. So 6, 8, 48, 2.
percentage sign is what's called a modulo. And that it just takes what is left over. So 50 divided by 6 is not divisible. There is a leftover. So if we print that, you'll see we get a leftover of 2, which makes sense because 6 goes into 50 8 times. 6 times 8 is 48. And then we have 2 left over. So if we want to know what the remainder is, we can use a percentage sign here. We can also do something like 50 divided by 6, like we saw earlier. And this will have division with remainder. So we can say or float. We'll save that and take a look at that really quick. You can see we get 8.3, and then it rounds up eventually to a 4. And lastly, what if we wanted no remainder? So if we just did 50 divided by 6, we say no remainder. We could do this, and we should get 8 here. So depending on the situation and what we want, we might want a situation where we only want the integer, or we only might want what's left over, or perhaps we actually want the full number of what's being divided. So there are a few different ways to divide with math in Python, and it's good to know all of them depending on the situation that you run into. So for now, just take notes on this and know that there are a few ways to do math and division, and you can do PEMDAS and exponents and all kinds of fun stuff, and this is just scratching the surface of math with Python.
Base 44 super agents. Careful, there's no going back. No setup. Just say hello.
So that's it for this lesson. We're going to go ahead and move on to the next one, which is going to start covering variables and methods. So I'm going to come in here, and I'm just going to call this section variables and methods. And if we want to make our script a little bit clean, we can just come in here and copy this new line. It'll be a lot easier once we write a function for this, but we haven't gotten there quite yet. So we're going to print out this new line, and that way when we print this out, you can see that we have kind of gaps in between the sections that we're working on. So now we're going to work on variables and methods. So variables. A variable means something can vary. It can change, and we're going to look at that here in a second. So if we have something like quote, and we make quote equal to all is fair in love and war, and this is what? This is a string. We are storing the string inside of this variable called quote. And we can just come in here now and we can print out quote. And if we do that, we should get this returned back to us. You can see all is fair in love and war. If we didn't print this, just go ahead. Actually, we'll just comment this out. This is a great way to test the script. If we just save this now with a comment and we hit enter, there's nothing here. We haven't given it any instructions to actually print out. So
Don't worry, I know what's going on.
now we can print this out.
So what they did was, actually we can go here, Kali. Just going to write print n and print variables and string quotes. Print this is a string. And Python 3 first.py. Oh, come on. Do that. Right, so Python 3 first.py. There you go.
This out, and it's printing whatever is stored inside of that variable. In this instance, we have a string stored in there. Now, when we talk about methods, methods are just functions that are available for a given object. Now, you can think of functions as something built into Python that allows us to do something. And it'll make sense here when we get into using methods. So we have this quote, all is fair in love and war. Well, what if we wanted to print this in a few different ways? Well, we can use methods to do that. For example, we can print quote in uppercase. Just do upper like that. And this
Oh yeah, quote.upper, quote.lower. So let's do print and print quote.upper, print quote.lower. And Python 3 first.py. Okay. Oh yeah, okay. I never defined it. So let's say quote will be this is, oh wait, I know one. I love Valentina Gomez Noriega. Python 3 versus PY.
This is going to make it all uppercase because we're giving it this period, upper, and then open close parentheses right here. And that is allowing us to use that method. So we can say uppercase. And we can also print in lowercase. We do lower. And just for one more, we can also do print, and we'll say quote.title. And this is what's known as title case. And title case will capitalize every single letter like it is the title. In this instance, here we're going to get like the A capitalized, which wouldn't really be true in a title, but still just know that title case is meant to capitalize every first letter within your string or your sentence in this case. We're going to call this lowercase here. Okay, so let's go ahead and save this, and we're going to print this out. And you can see the differences that we have. We have it here in its normal quote, and then we have it in uppercase, all lowercase, and then every single first letter capitalized. Perfect. These are methods. These are just a small example of methods we're going to get into more a little bit later. Here's another example. What if we wanted to print the length of quote? Let's say we wanted to know how many characters were within this sentence. So this is going to count the characters. And this will also count spaces. So we're trying to get a total count of what's going on inside the string. We print that. You'll see that we get 28 return. So if you want to check that, you can go count every single character within here, and you'll get the length of that. And that could become important as you're doing Python later on. And this is just yet another example of a method. Now let's go back to looking at variables and why they're called variables. So let's say that we have a variable of a name. And in this instance, I'm going to use my name, and I'm going to make.
So, although I know them, print quote.title. What this will do is Python 3 versus py. So it's going to, so I'm just going to snip those. So, wait. Oh, come on. This does all uppercase, all uppercase, all lowercase. The first letter for each word uppercase.
Make it a string, and I'm going to use my age. I am 33, and here we're going to say string just so we can make sure we notate the differences. This is an int or an integer, and we're also going to give a GPA. Let's say I went to school, and I'm going to use the American grading system. Let's say I had a 3.7 GPA, and this is what's known as a float, and that has a decimal, so make sure you notate that. So if we print these out, we print out the integer of age, that'll still print 33. What if we print out the integer of 30.1? Save that, take a look.
He's going to print 30, yeah.
And you'll see that we just get 30, all right? And you can see that this rounded down. Again, integer, just the first number, just what's on the left side of the decimal point. Doesn't care about the right side. What if we printed integer of 30.9? Will it round?
30.
Will it round? No.
30.
So if we save that and we print again, you'll see it's still 30. It doesn't care what's on the right side of the number. It's only going to take what the integer is. So anytime you print an integer, you're only going to get the first, or what's on the left-hand side of the decimal point. So make sure you know that. Now, a few cool things that we can do. Let's say that we wanted to print something like this. If we print my name is with a space, and then we'll do plus name, and we'll say space again, and I am space age plus space years old. Make sure you have your spacing in there properly. That way you can count for the spaces before and after these variables. But what are we doing here? We are concatenating variables. Now, if I try to run this, I'm actually going to get an error. If I run it, we're getting a type error. And this is a great example, by the way, of understanding what Python is telling you. I get emails all the time from students saying, I don't understand why my script isn't working. And the first thing I'll ask them is I will say, did you read the output of the error? Because it tells you. It says, hey, on line 44, if I control tab, look, this is line 44, it tells you where your mistake is. And then it also says, it only concatenate string, not int to string. So if you didn't know what this meant, and maybe you don't, you can copy this, go to Google and search it, and I promise you, somebody will have had this error before. As much as we wish to be special, there's not many situations that will come up where there hasn't been this error or an issue that we run into that somebody hasn't already had before. So with that in mind, we can fix this. So it's saying that it can only concatenate strings, not integers. Well, name is a string, but age is an integer. So we need to make, in this situation, age a string. So what we're going to do is just say str, like this, and give it like that. And now if we print this, save it, print it, and see, my name is Heath and I am 33 years old. Perfect. Now, what happens if I am a year older? Well, I could take age and do something like plus equals 1, something like that. And if I print age now, hopefully, we are seeing 34. You can see 34. Now, this is what comes into play. This is a variable. Variables can change. At this point in the script, we define that we are 33. And as we run through it, I am still 33 when I print this statement out. However, I've had a birthday now. Age has increased by 1. Printing age out now will say that I'm 34. So variables can change. Variables can store different numbers at different times. That's why they are called variables, because they vary. Now, we could also do something like birthday and set birthday equal to 1. And I could say age plus equals birthday and then print age. And guess what? Now it's going to return 35. So just know that you can store a number within a variable. We've shown that before already. We can add two integers together and we can print them out. So we're adding those together and it's taking that total and adding that to age. And now it's saying we're 35 years old. So that is it for this lesson. We're going to go ahead and move on to functions and fix this new line issue that we've had, plus write some pretty cool stuff out and build some other cool functions out as well. So I'll go ahead and see you over in the next lesson.
This game, you're not ready.
All right, moving on to functions. So let's go ahead and print out a new line really quick.
I'm just going to copy those because I already know them. We're snipping to copy them quickly. Go on Joplin. Pew, pew, pew. Now these are functions. Now we are on functions. Python functions.
Really quick. And we're going to call this functions. Now, I like to think of functions as mini programs. What they are is an organized block of code that you define, and then you can call it later instead of repeatedly typing the code out. We're going to take a look at some examples of that. So let's go ahead and write a function. So let's do a define, def, and that's how we start a function. And in this one, I'm going to say, who am I? And I'm going to do close parentheses. And here, we're going to say, this is a function without parameters. And we'll talk about that here in just a little bit. Now, indentation is incredibly important in Python. If we do not indent, we will throw an error here. And you're going to see a lot of situations where indentation becomes incredibly important. It's one of the most important things in Python. Python does not have a lot of rules that apply to it, but indentation is one of them that you must follow. So we're going to go ahead and hit the tab to indent, and I'm going to say my name is Heath. And this is what is known as a local variable. We'll talk about that here in a second as well. Age is equal to 30. And we're going to go ahead and print. Same thing we did before. We can actually just kind of copy this up here. We'll say my name is just like this, okay? Copy all that, paste it, and then add the close parentheses there. I'll let you catch up. And then we can just call down here, who am I? So what's going on in here? Well, we have a function that we're defining. We're calling it who am I? And it has no parameters. We'll get into parameters here in just a second. Now we're giving it some items within this. In this instance, what we're doing is we're giving this local variables. We're saying, hey, in this instance, when we have a variable of name, it's going to be Heath, and the age is going to be 30. Well, whatever is stored in here is only stored within the function. That's why this is a local variable. If we print age as well, we'll see that. So we know that age was 35. We called age over here as 30, and let's see what happens. First of all, we called our function here. We said, who am I? Called that. And all it does is run our mini program. Our mini program says, hey, I'm going to print out these variables into this string here. Okay? And that's exactly what it did. But when we printed age again, you can see that we're actually still 35. So this variable, or the variables that are within a function.
This is the what's typically what's going on is that I can actually code this out. I have, okay, let's put it Kali. I'm just going to do that print. Then if I write define my identity, I'm going to have a name as Sarkar, age 22, GPA 3.93. I'm just going to call my identity. I'm going to print. Oh, wait, that'll be inside the function, right? Yes, that'll be inside the function. The print. My name is name. Oh, don't you do that? My name is name. Aged. Age with a GPA of GPA. I'm gonna write Python 3 first.py. Oh, my bad, I haven't finished it. Python 3 first.py. What? Python 3 first. Okay, Python 3 code first.py. Okay, now I think I have a mistake here. Maybe because what I have to do is instead do this and then do this again. I think it should be like that. Python 3 first.py. Okay, what's the mistake I made here? What's the mistake I made here? That's what I want to know. What's the mistake I made here? Then write the correct code. There you go. For that, name age. I can just go down, save Python 3 first.py. There you go.
Are local and do not apply outside of the function. So make sure to remember that. Okay, so I'm going to delete this print statement. We don't need it. And we're going to write some more functions. So let's do one where we add some parameters. So we're going to do add 100. And we're going to give this a parameter of num, N-U-M. And that's just going to stand for number. Okay, we're going to indent, make sure we indent. And all we're going to do is print num plus 100. So when we call our function, we say add 100, just like last time. This time we have to actually give it what is called an argument. So our argument goes with our parameter here, and we're calling it. So our argument is going to be 100. And when we print this out, this is going to be 200, hopefully. So we'll save this, run it. And you can see that we got 200 because we're doing print 100 plus 100. That's all we're doing, is this mini program. Okay, let's try another one. Let's say we want to have multiple parameters. Let's do define, add, and we're just going to add.
What are the requirements for a cybersecurity analyst? What are the requirement programming languages for a penetration testing engineer? I have a question. Which roles closely correlate to hacking? Penetration testing. So currently I am learning from Keith Adams. I mean, everyone knows him, from CyberMentor for penetration testing engineer. Is that a good start? I mean, yes, obviously, because it's Keith Adams. Everyone knows him.
Add x and y. This one's going to be easy. We're just going to say print x plus y. And now we can add whatever we want. So let's add 7 and 7. And one will take the place of x. The other one will take the place of y. X plus y. 7 plus 7 should be 14. Let's go ahead and run that. You'll see we get 14 here. Beautiful. All right, x plus y. 7 plus 7 should be 14. Let's go ahead and run that. You'll see we get 14 here. Beautiful. All right, let's make it a little bit more complicated then. All right, let's try adding in here another function. This time we're going to do multiply. We're going to do x and y again. And instead of doing a print, I want to show you something a little bit different. Let's say we just return x times y. Now, in this instance, if we multiply 7 times 7, do we get 49? We don't. Okay, there's a reason for this. This is just calling back. So when this is saying return, this isn't saying print. Remember, this says print. This is going to return x times y. So we can call this here, this function, and it knows that this function is equal to 49, and perhaps we can put that into something else. Like we can put that maybe into a variable or whatever it is we might want to do with it. However, if we wanted to return to the screen, we actually have to call that. So sometimes we're going to actually store something instead of printing it. We do a lot of printing in Python tutorials just so that you can see it on the screen and make sure that you're seeing what you're doing and that everything's printing out okay. So that's why we're doing this, but please understand that the return option does exist and is used quite frequently. So I'm going to save this and run this, and you can see now that we get 49. Perfect.
This is actually kind of crazy. This is your brain on normal music. Jumping between tasks, losing.
Okay, 2 more. Let's say we want to do a square root. Okay, so let's define square root, and we're just going to give it 1 parameter. And in this instance, we're going to print out the square root. So we're going to take x, and a square root in exponent format is just to the power of 0.5. That's all we're doing. And we can test that theory by doing something like square root of 64, which we should return as 8, because 8 times 8 is 64. So if we save that, come in here, print it, and you can see we get a float of 8.0. Now, I told you we would create our own function for a new line, and we're going to do just that. Let's go ahead and define a new line. And we could call this like
Dude, I swear I keep getting like, I don't know what's going on, man. I keep getting I create something, then they ban me, then I create, then they ban me. Holy fuck, man. I just hate this shit. They keep on banning me. Just wait, just wait. There you go. What mail is this? Oh, there you go. Wait. Do not. Do not. Do not. Do not. Do not. Do not ban me. Do not ban me. Come on. Four nine five one nine. Just give me 2 seconds. 495 194. Skip for now. Nope. Fuckers. I may have